Right. So last time we started studying matrices. Matrix is an array of numbers, right? Rectangular array of numbers. Something like this. Nij, suppose this is an n by n matrix, meaning that we have entries like A11, A12 up to A1 n. So we have n columns and rows. And 1 and 2 and n. Okay. It's an n by n matrix. And row and column. Okay. If we have an let's say n by n matrix and n by let's say L matrix, then we define its product C, which is then so this here the number of columns should be the same as number of rows. Then we get an n by L matrix, and we've seen last time that if C is elementCij's, then this Cij is nothing but this summation. So let me write it this way. I think ith row of this. So ith row means I1, and then nth column of this. So B 1L, and then I2 B 2L. No. B2 J on the plot. I take J column. J up to B I no A I and B and J. Okay, so maybe this is what we do. If this is the matrix A, this is the matrix B, and here I have Cij. So here I take ith column AI1, AI2, AIN, and here I take jth row. So B1J, B2J, up to G and J. Okay, so I multiply this row, ith row, with the jth column this way, and I obtain the ijth entry of the product. Last time I gave you one exercise. What was it? So we want to show the multiplication, matrix multiplication, of course, is associated meaning that A times B times C is the same as A times B times C. Okay? For any three matrices. If they have, of course, compatible sizes, for technical products. So the number of columns of this one, yes, should be the number of rows of this one, and the number of columns of this one should be the number of the columns of the third one. In this case, these two different looking products are the same. Bunu uğraştınız mı? Okay, let me do this. All right, let's just give names to these gadgets. So let's B to be B times C and B to be A times D. Okay. Now A is an, let's say, M by N matrix. M by N matrix. B is N by L matrix. Right? And C is what? L by P matrix. Okay. So what is B then? B is B times C, B times C. So it's then N by P matrix, and E is A times D, A times D. So it's an M by L matrix. Okay, and what we are asked to show is this, so we just must show A times BC. BC is just D is equal to AD, which is E times C. So this is what we are asking. Okay. So let me just write down what these are. Okay, I'll change the board. I figured it out what was wrong. So it is actually the first thing one should think about when an electronic device, doesn't work. What you should do, unplug and then plug, right? So that's the thing I had to do, but I just didn't remember. Okay, all right, so so what is the ij entry of D? So Dij, what is Dij? D is just B times C, right? So this is B times C. So this should be just B I K and then C K J and K from where to where, the common index. B and C, the common index of B and C is just L. So from 1 up to L. Okay. And what is the okay, let's say RS entry of AD. Şöyle diyeyim. Okay. Buna da bir isim verelim olmazsa. Let's call this guy F. And this one G. So F is this matrix and G is this matrix. Okay. So I should F is just the matrix F. Okay, maybe I should say ij dersem ne olursun? Fij. So what is Fij? Fij is just F is A times D, so A I okay R and then D R J and R is from where to where? And 1 to A is so it should be N, right? Okay. So Fij is, let me rewrite this from 1 to N, and then A I R DRJ. DRJ is this expression. So instead of R, I have R here. So if I make this R, then I will have R here, right? So what we have, summation over K from 1 to L, B, R, K, C, K, J, right? So what we have is this, summation from 1 to N and summation from 1 to L. Ya da bunları şöyle yazalım. 1 to M, no, N, sorry, and summation of K from 1 up to L, A, I, R, B, R, K, C, K, J. Okay. And we also have to compute the same for G. So let's see. G is okay. G için tabii ki A'ye ihtiyacım var. A is A times B. So let me just write down RJ. So what is this? Ya da IJ yazayım da ondan sonra değiştireyim. IJ, what is this? A times B. A, I, K, B, K, J, K from 1 up to where? N. Okay. And then we have G, which is E times C, right? So IJ entry of this Gij is what? Summation over R from 1 up to, let's say, ya da buna şimdi S from 1 up to no. E and J, J L. So it should be up to L. S from 1 up to L. E S, no, E I S, and then C S J, right? Okay, so Gij is S from 1 up to L, C SJ, and then EIS. EIS is what? EIS is just summation from K up to N. A, instead of I have S, so I will have S here. S, So, A, S, K, B, K, J. So this is just summation of S and K. Sorry. A, S, K, B, K, J, C, S, J. Efendim? So. Efendim? Well, this is just notation. There are two sums here. Summation over R and well, this is just notation. I mean, this is the same thing as this one. Just notation. When I write it here, it means this is a summation over two indices. Right? It is the same as this one or this one. Since summation, in a summation notation, you can do this. Nasıl? Burada yanlış mı yazdım? Bir dakika. Şu i olur. Yok. I S. Yanlış mı yazdım? I S. Oh, okay. Oh, sorry. Yeah, here I have EIS. EIS is what? Okay, I write S here. What S here? AIK. BKS. Sorry. Okay. Now we have to check that these two summations are the same. Okay. Let's see. Here I have indices I, R, K, RK, and then KJ. So, okay. Ne yapmamız lazım o zaman? So instead of IK, I need to write IR. This means that I am writing R for K. So instead of K, I will write R here, R from 1 up to N, and then B, K, S. Here I have K. So S yerine de K yazacağım. So instead of S, I will write K. Instead of S, I will write K. And then C, S, I write K, and J is J. So they are the same. Okay. These two are the same, only the letters are interchanged, and you see that this is the same as, so Fij is equal to Gij for all ij, hence F is equal to G. Okay. F is equal to G. So there is nothing difficult or complicated about this. All you have to do, you have to be careful to keep track of the indices. Okay, that's it. And keep in mind what the definition of product. Tamam mı? Sorusu olan var mı? All right. All right, so what else? Okay. There is this exercise. How we make the C's. Sigma 1, sigma 2, sigma 3 are defined as follows. These are some matrices used a lot in physics, I guess quantum mechanics. 0, 1, 1, 0. Sigma 2 is 0 minus I, 0. So they are complex matrices, okay? And sigma 3 is 1, 0, 0 minus 1. So one can verify that. Okay, check that. Sigma I squared. Square of each one is identity matrix. The author used this notation to denote the identity matrix. What we mean by the identity matrix is this: 1, 0, 0, 1. And sigma 1 times sigma 2 is I times sigma 3. Sigma 2 times sigma 3 is just I times sigma 1. And so on. So sigma 3 times sigma 1 is I times sigma 2. Okay. All right. So you are asked to show these identities for these matrices. Okay. Linear equations. Now, for example, consider the following system of linear equations. You have seen such kind of equations in high school, right? Or in math 15 or 16. 115? 116. Okay. I can write this equation using matrices as follows. Write the coefficient matrix. So I look at this coefficients 2, 1, 3, minus 1. And write here x and y, considering x and y as if they are real numbers. And this is equal to minus 11 times and 6. What we mean by this, you see, when you multiply this, you will get what? You get this, right? 2x plus 1, 2x plus 1, sorry, plus 1. 2x plus y, and then 3x minus y. 3x minus y. This is the 2 by 1 matrix, right? 2 rows and 1 column. And here I have again the same thing. 2 rows and 1 column. These are equal means right? If these are equal, then of course all the entries must be equal. One entry here is this guy, and it is this one here. So we have 2x plus y equals minus 11, and 3x minus y. This is equal to 6. So we can always write down linear equations in matrix notation, like this one. Şimdi bunu let's do one more example. Write the system. Below in matrix notation. Suppose it is this one, x plus y minus z equals 0. Y minus x plus 2z equals 0, and 3y equals 2. If it is given like this, one has to be careful so that you should have the indeterminates in the right order. Meaning that here you have x, y, and then z. You should have them in the same order. So first x term should come here, so minus x, and then plus y, and then 2z equals 0. And then here you have 3y equals 2. Okay. So in matrix notation, this will be what? First row, 1, 1, minus 1, 1, 1, minus 1. The second row, minus 1, 1, 2, minus 1, 1, 2. And the third row, 0, 3, 0, 0, 3, 0. And this is equal to 0, 0, sorry, I forgot x, y, z. X, y, z. And here we have 0, 0, and 2. Okay. Nasıl?
Telefonu burada sesli şimdi çok fazla ses geliyor. Tamam gibi oldu ama sen de söylediklerini sürekli şey yapıyor.
Tamam, anladım. Yanlış tahtada bakıyormuşum ben de bu arada. Okay, so yani titreşimi kapatmasını istiyorsunuz değil mi? Tamam, tamam. Okay. All right, so we will come to all these topics during the course. I mean, and spend time on them. This is just to get used to the notation. So we will come to. I mean, we will study linear systems in detail I will stop at the moment, but then we will come back again, okay? Inverse matrix. Here, I will tell you how we solve these systems. We will study them later, okay? Okay. Now, let A and B be square matrices of the same size. Let's say n by n. Okay. We say that A and B are inverses of each other. If A times B is the identity matrix, and B times A is the identity matrix, where is the n by n identity matrix. So what is this? This is just this matrix. I have ones in the diagonal, and all the other entries are 0. Okay. So it's an n by n matrix. Everything is 0 except the diagonal elements, and diagonals are all equal to 1. Why do we call this an identity matrix? I guess you all know, but the thing is the following. So let me switch the board. It's called identity because when you multiply a matrix with the identity, you get the same matrix. Okay, so it's called the identity matrix. Since this times any matrix is A and any this. So unit element in the multiplication, okay, of the multiplication. I shouldn't say unit. Unit has another meaning. It's the identity element. Türkçe'de birim eleman diyoruz ama İngilizce'de unit deyince başka anlamı da var. Tersi olan her şeye unit diyorlar. Ama identity onların için özel bir şey. Now let's see why this is true. So let me write this. What is the ij entry of this? Let me write it this way. Ij entry of this matrix. What is the ij entry of this? Well, it is summation from 1 to n. Ith element of this matrix, and then kj element of this matrix. You multiply them and add them up. However, what is the ith element of the identity matrix? Ith row and kth column. It is either 1 or 0, and it is 1 exactly when these two indices are the same. So this is always 0, except only one value of k. Which one is that? When k equals I. So this is always 0, except k equals I, and when k equals I, it is just 1. So the summation is just 1 times this element. But This is 1, then k is equal to I. So here k is I, so I have Aij. So what we see is that ijth element of this matrix is the ijth element of the matrix A. So this means hence 1 times A is what A. Similarly, you can compute this and it will be A. That's why it is called the identity matrix. And we call a matrix inverse of the other one if so, and we are called inverse of each other if their product is identity, but in both ways, okay? All right. How many identity elements can we have? Well, this is an identity element. But you can ask the following question. Is there any other matrix having the same property? That it acts like identity. Right? So here's the question. Is that any matrix, n by n matrix, of course, let's say epsilon, okay, n by n matrix, so that epsilon times A is A, and this is this. Yeah, I am asking whether it is unique or not, right?
Yeah, it's not unique.
Not unique?
I think it's unique.
Sorry?
Bence o identity olan bir sürü vardır hocam.
Bakalım, tamam. Oylama yapalım. So what do you think? Can I find a matrix like this other than the identity one? So you say there are. You?
No.
No, okay. Oh, yeah, good question. For all of it. Right, we have one identity, but maybe there is another identity element. Inverse of identity. Okay, we'll come to that also. So the answer is there any other matrix? Maybe I should say, right? Any other matrix? Other than the identity? The answer is no. But one should prove this, right? Just professor said there is no other is not enough, right? One should prove this. So one must show that if there is an epsilon satisfying this, then this epsilon is nothing but this matrix. Proof. So assume that epsilon is a matrix satisfying epsilon times A is equal to A, and that's equal to A times epsilon for all n by n matrices. Then I have this. Identity element is an n by n matrix And since I have this equality for all A, I should, that should be true also for A equals identity. So this should be just this. Değil mi? Madem bu identity sağdan veya soldan çarptığında değişmemesi lazım. But we know that this is also identity. So 1 times this should be just this gadget. So I have epsilon. So this identity must be the same as this identity. This means what? There is only one identity element.
Ben şey, o A için özel bir aydın.
Tamam, tamam. Yani A ile çarptığımızda identity veren yok. A veren tamam, tamam. Tabii A'yı mesela 0 alırsan, değil mi? Neyle çarparsan çarp 0 verecek mesela. Tamam, okay. Understood? What about inverse of a matrix? Can we have more than one inverse? Hmm? Left inverse. Let's see. But here, what I mean by inverse is this. So A times B and B times A should be both identity, okay? So that's the definition of inverse. You are right, there are also definitions like left inverse, right inverse, but now here I just defined inverse of a matrix. And what is the inverse? Inverse of A is just a matrix B satisfying both equalities. Okay. So in fact this a matrix an n by n matrix A can have at most one inverse matrix. One inverse cannot have more than two, more than one. Why is that? Proof. Forgetting olmaz. İspat değil. We assume that let's assume that there are two inverses. Let B and C be two n by n matrices. Both satisfying. B is an inverse, so A times B should be identity, and B times A should be identity, and C is also an inverse, so A times C, this should be identity, and this should be identity. Okay. We must show what? Must show B is the same as C, right? If there are two matrices satisfying the inverse property, then actually they have to be the same. Where is that? Well, let's start from B. B is the same as B times this. Okay. What is 1? 1 is, well, I can use, for 1, I can write this one, this one, this one, or this one. They're all 1. So which one should we use? Let me use this one. A times C. Okay. But we know that multiplication is associated, so I can write it this way. And then I look at my list again. B times C, B times A. B times A is also identity. All right. Times C. So this is identify C is just C. So what we have seen is that B is the same as. So there is only one inverse element. If there is, of course, sometimes there is no inverse element. But if there is an inverse element, then it has to be B. Okay? Tamam mı? If there is anything you don't understand or you don't believe, just ask. Remark. Not all non-zero square matrices have an inverse. For example, consider this one. Let A to be this matrix. 1, 0, 0, 0. Okay. This matrix has no inverse. Why is that? So I claim this. A has no inverse. Why is that?
For example, maybe we can write equations like, for example, when we multiply this one with a square matrix again, for example, x, y, z, t. Again, if it has an inverse, that would have, I think, an identity as a result.
Okay.
And when we by using or by writing equations, maybe we may have contradiction.
Okay, so you are saying this, right? Let give you an inverse for 8. Then anytime B should be identity, right? Suppose we know that A is this, and B has entries B11, B12, B21, B22, and this is identity with 0, 1, 0, 0, 1. And then let's do this multiplication. So what is this? B11 plus 0. So I have B11. And then B12 here. And then 0, 0. I have 0 here. And 0, 0, another 0. So this is the same as 1, 0, 0, 1. But if these matrices are the same, then all the entries must be the same. Okay, no problem with this, no problem with this one. This is okay, 0 equals 0, but here we end up with this. 0 should be 1. Okay, so this implies 0 equals 1, which is a contradiction. The reason we arrived at this contradiction is our assumption that there is an inverse for A, right? There is an inverse for A. So A has no inverse. Tam buçuk mu oldu? Tamam, okay. Let's have a break.